This is part 2 in the series. If you haven't seen part 1, please go back and look at it first. But this is 2 of 4 of Sumerian cultures.
Sumerian art is dominant with the mineral lapis lazuli. This Sumerian commodity has a unique signature only found in one specific place on Earth, the Sari Sang lapis mines, which show extensive mining for 6,000 years. In the standard of Ur shown here, now housed in the British Museum, it demonstrates just how lapis dominated their art. We even get another clue in this object to the clothing they wore. This combed sheepskin attire, unusually unique, is reminiscent of ancient Turkmenistan cultures. We see an individual playing an ancient harp on the standard of Ur, also housed in the British Museum. This beautiful Sumerian harp reconstructed from the standard of Ur imagery with lapis lazuli. From the same archaeological finds, we have the delicate ram in a thicket, a composite of gold and lapis, an artistic concept of combining these two valuable minerals we see spread as far as Egypt. The Ishgar Gate, now housed in the Pergamon Museum, shows the beautiful lapis glazed tiles. It also gives you an idea of the quantity and sheer distance they transported this material. Sumerian gods and early statues always depict blue eyes, a significant feature in their artistic representation, physically and methodologically, as their lapis eyes look to the lapis heavens. Biogeographic research involving haplogroups does indicate some influence from Turkmenistan, but you would expect that if you mined or traded the quantities of lapis there. Here is the other problem. When you look in that region, you find ancient settlements and artifacts similar to the Ubaid culture. Was there an Ubaid influence in Turkmenistan? Gono tape, Anu, and other Neolithic settlements are incredibly similar. These artifacts of Gono tape show a close resemblance to Ubaid art. It really does seem when you go looking for Sumerians, you find the Ubaid culture too.
And in Göbekli
Which brings us
Tepe.
to the same problem of when exactly they fused together as one culture. The only thing we do know for sure is the Sumerian language is completely isolate. It is as if they were inserted into Mesopotamia, fully equipped with an amazing, highly evolved skill set. Trade and commerce can provide interesting evidence, but it does not prove origins. It proves how extensive their trade network was. In the centuries that followed the immigration of the Sumerians, the country grew rich and powerful. Art and architecture, crafts, religious and ethical thought flourished. The Sumerian language became the prevailing speech of the land. The people here developed a cuneiform script, the system of writing on clay. The script was to become the basic means of written communication throughout the Middle East for a further 2,000 years. The rise of the Sumerian civilization from obscurity to enlightenment is phenomenal. There is no doubt about that. There was no trial and error, no evidence of a slowly evolving civilization. The Sumerian civilization almost sprung into existence overnight. In the space of a relatively small window of time, the leaps and bounds in technological, artistic, spiritual, and architectural achievements are breathtaking. We desperately cling to discover a trigger for this. One particularly bright leader or visionary doesn't do it. There is no evidence for that. No influence from another neighboring, advanced regional culture either. It is as if the Sumerians were savants from day one. The legacy of the Sumerian savants is highly significant. They were advanced business administrators and used a system of counting based on the unit 60, the sexagesimal system rather than the decimal system, which is based on the unit 10. The sexagesimal system is still used today in computing divisions of time: 60 seconds to a minute, 60 minutes to an hour, a day of 24 hours, and a week of 7 days.
12 months in a year.
They based their angles, divisions of 360, multiples of 60. They also created a lunar calendar, attributing more importance on the movements of the moon, unlike the Egyptians, who worshipped the sun. We know this from their worship of the lunar god Nana in Akkadian Sin. There is an extensive array of data provided by archaeology on Mesopotamian astronomy. However, the intellectual approach of the Sumerian savants has never been analysed scientifically. Presumably, they observed the motions of the moon before the appearance of writing. The need to record lunations precisely and repeatedly simultaneously gave rise to the invention of time and writing. This was an incredibly important step in abstract thought. The abstract thought didn't stop there. Recently discovered evidence shows they tracked the motion of Jupiter using a precursor to modern calculus, the area under a curve. Babylonian astronomers used simple arithmetic to predict the positions of celestial bodies. They also employed sophisticated geometric methods that foreshadowed the development of calculus. Historians had thought such techniques did not emerge until 14th century Europe.
They also have trigonometry. Look up my video on Sumerian trigonometry. One of the tablets they found shows a better and more accurate form of trigonometry than ours. Notice the lion has a wing attached to his
Although
side.
the tablets prove Leibniz and Newton newly rediscovered calculus, the revelations didn't stop there. Matthew Ossendriver of Humboldt University in Berlin bases his findings on a re-examination of clay tablets dating from 350 BC to 50 BC. They even contained instructions for constructing a trapezoidal figure. It was assumed unrelated to anything astronomical. Ossendriver studied two other tablets that also prescribed the drawing of a trapezoid, and in these he thought he could make out a reference to Jupiter. The giant planet was an obsession among the Babylonians, who equated this planet with their main god Marduk, the actual patron deity of the city of Babylon. But the Jupiter link was tentative. Retired Assyriologist Hermann Hunger of the University of Vienna visited Ossendriver, bringing photos taken decades ago of an uncatalogued Babylonian tablet from the British Museum that described some of the astronomical computation. Alone in his office a few months later, Ossendriver perused the photos. Images were blurry and the inscriptions slanted, making them hard to read, but he realized the numbers were identical to those in the trapezoid inscriptions he had been scrutinizing. By comparing the photos with fragments of other Babylonian texts, he discovered that the computations described the motions of Jupiter. Examining all of the tablets at the British Museum, Ossendriver figured out that the trapezoid calculations were a tool for calculating Jupiter's displacement each day along the ecliptic, the path that the sun appears to trace through the stars. The computations recorded on the tablets covered a period of 60 days, beginning on a day when the giant planet first appeared in the night sky just before dawn. During that interval, Jupiter's motion across the sky appears to slow. Such erratic apparent motion stems from a complex combination of Earth's own orbit around the Sun with that of Jupiter. A graph of Jupiter's apparent velocity against time slopes downwards, so that the area under the curve forms the magic trapezoid. The area of the trapezoid in turn gives the distance that Jupiter has moved along the ecliptic during the 60-day period. Calculating the area under a curve to determine a numerical value is a basic operation known as the integral between 2 points in calculus. Discovering that the Babylonians understood this was the real aha moment. Delving into older, purely mathematical Babylonian texts written between 1800 BCE and 1600 BCE, which also described computations with a trapezoid, he realized that the astronomers who made the tablets had gone a step further. To compute the time at which Jupiter would have moved halfway along its elliptic path, the astronomers divided the 60-day trapezoid into 2 smaller ones of equal area. The vertical line dividing the 2 trapezoids marked the halfway time. Because of the different shapes of the trapezoids, it indicated not 30 days, but slightly fewer.
A month.
The Babylonians had developed abstract mathematical, geometrical ideas about the connection between motion, position, and time that are so common to any modern physicist or mathematician. Their presence testified to the revolutionary brilliance of the unknown Mesopotamian scholars who constructed Babylonian mathematical astronomy. After cuneiform died out around 100 AD, Babylonian astronomy was thought to have been virtually forgotten. It was left to French and English philosophers and mathematicians in the late Middle Ages to literally reinvent what the Babylonians had invented, developed, and ritually practiced as far back as 1800 BC. Without doubt, learning how the Babylonian astronomers acquired their geometric acumen, their mathematical prowess, their abstract reasoning would tell us something about why human beings do science in the first place. The legacy of Sumerian civilization was completely adopted in its entirety by Babylon. The only thing we can say for sure is that the trail of the savants in this region on the level of Newton goes back to 1800 BC as a minimum.
That's part 2 in the series. Upcoming is 3 and 4. Again, look up Sumerian trigonometry. Like, sub, and share.